There are many things to cover when it comes to different parts of a car and what they do, but starting with the basics is key. Having a foundational knowledge of the major components and car functions in your vehicle will serve you well in the long run. Here are the main parts of a car. An engine is a machine that burns fuel and converts it into mechanical power. Most modern vehicles use internal combustion engines, ICE, which ignite fuel and use the reaction to move mechanical parts. ICE engines burn gasoline or diesel fuel to drive pistons up and down, turning the crankshaft and eventually moving the vehicle's wheels. Technicians measure engines by the number of cylinders and the volume of those cylinders. For instance, a 350 V8 is an engine with 8 cylinders arranged in a V formation, displacing 350 cubic inches. It's not uncommon to hear someone refer to the engine in their electric car, but EVs do not have engines, they have motors. Motors are machines that convert electrical energy into motion. No matter which type of engine you've got, your car won't be going anywhere without it. A car transmission is one of the most important components of a vehicle. It's what moves the power from the engine to the wheels. There are a variety of car transmissions. Some are automatic, while manual transmissions in stick-shift cars require the driver to complete extra steps for the vehicle to operate effectively. Where is a transmission in a car located? Typically, a transmission is mounted onto the chassis of a vehicle in the front. If you've wondered about how a transmission works, the process varies depending on the type of transmission. Whatever type of transmission it is, the answer to what does a transmission do is to enable the gear ratio between the drive wheels and engine to adjust as the car slows down and speeds up. When a vehicle is stopped, the transmission disconnects the engine from the drive wheels so that the engine can keep idling when the wheels aren't in motion. Transmissions also enable quick acceleration from a stop and enable the engine to run more slowly to cut down on wear while the vehicle is driving at consistent speeds. The battery is the foundation of your ride. It helps provide the jolt of electricity necessary to power all the electrical components in your vehicle. Talk about a pretty huge responsibility. Without battery power, your car, as you've probably noticed, won't start. The car battery is part of the starting system. There are 3 main components in the system. The ignition switch is either the starter button you press or where you insert your key. The switch controls the starter relay, also called a solenoid. When you turn the ignition, it sends a small electrical current to the starter relay. This causes a pair of contacts to close. When those contacts close, the battery sends voltage to the starter motor, which turns some gears to start the car. Choosing a car battery can be a bit overwhelming. Cold cranking amps, group size, reserve capacity. What does it all mean? Let's break down some of the common terms you'll run into when buying a battery. Battery group. The first thing you'll want to consider when picking out a new battery is the battery group. It determines the dimensions, voltage, 6V or 12V, and terminal locations of your battery. To ensure that your battery fits, you'll want to match your battery group to your specific vehicle, which can be found in your owner's manual. Cold cranking amps, CCA. If you live in a cold climate, you'll need to consider CCA. This number is correlated to how well a battery can operate in cold temperatures. The higher the number, the more powerful the starting power of the battery is. Reserve capacity. A battery's reserve capacity refers to how long the battery can deliver power to your vehicle without help from the charging system. The larger the reserve capacity, the longer the battery can provide power on its own. Trust me, you don't want to be left with a dead battery. It's a real disappointment. If you hear that clicking sound when you turn the key or notice your headlights dimming, it's a good idea to have someone check the battery. Better safe than sorry, right? When it comes to powering your car's radio, headlights, and other electronic components, you may think it's the battery that's putting in all the work. In reality, it's your alternator that keeps things up and running. Under the hood, an alternator looks like a small cylindrical generator. You will typically find it bolted to the engine. A car alternator, along with the battery and voltage regulator, is one of three main parts of a car's electric charging system. What an alternator does is supply electricity to be stored in a vehicle's battery. It is the alternator's function to take in mechanical power from a serpentine belt connected to the engine's crankshaft pulley and then convert this mechanical energy into electricity. Alternators do not demand much attention unless, of course, they are in failure. Most alternators will last anywhere between 7 to 10 years in ideal conditions. However, there are some ways to tell if your alternator is bad. Flickering headlights, dim lights on the dashboard, and trouble starting your vehicle are just some minor clues that your alternator is struggling. Radiator: a vehicle's engine gives it the power it needs through the burning of fuel and the creation of energy from its many moving parts. This power and movement can generate a tremendous amount of heat throughout the engine. It is essential to vent this heat from the engine during operation to avoid overheating, which can result in severe damage. A radiator helps to eliminate excess heat from the engine. It is part of the engine's cooling system, which also includes a liquid coolant, hoses to circulate the coolant, a fan, and a thermostat that monitors the coolant temperature. The coolant travels through the hoses from the radiator, through the engine to absorb the excess engine heat, and back to the radiator. Once it returns to the radiator, thin metal fins release the heat from the coolant to the outside air as the hot liquid passes through it. Cool air flows into the radiator through the car's grille to aid in this process, and when the vehicle isn't moving, such as when you're idling in traffic, the system's fan will blow air to help reduce the heated coolant's temperature and blow the hot air out of the car. After the coolant passes through the radiator, it recirculates through the engine. This heat exchange cycle is continuous to maintain an optimal operating temperature and prevent the engine from overheating. Front axle: an axle is a rod or shaft that rotates the wheels and supports the weight of your vehicle. Axles are essential components of any vehicle and come in three main types: front, rear, and stub. As its name implies, the front axles are located at the front of your car. The front axle's purpose is to support the steering and process the shock generated by the bumpy surface of the road. Front axles may either be live or dead. Front axles must be as sturdy as possible, and that's why they're usually made from carbon steel or nickel steel. Front steering and suspension are essential components of a vehicle that ensure driving safety and stability. The primary function of the suspension and steering systems is to allow the wheels to move independently of the car while keeping it suspended and absorbing road shock from being transmitted to the driver's hands. The steering system provides vehicle turning per the driver's will, directional stability, and converts the rotary movement of the steering wheel into an angular turn of the front wheels. The two most common types of steering systems are rack and pinion, used on most cars, and recirculating ball, used on trucks and utility vehicles. If some objects come out in front of your car, though, you might start thinking about how one part of a car works: the brakes. When the driver slams on the brakes, you'll be glad that they quickly bring the car to a stop, preventing you from a nasty collision. A car in motion has a lot of kinetic energy, which is energy of motion. To stop a car, the brakes have to get rid of that kinetic energy. They do so by using the force of friction to convert that kinetic energy into heat. When you press your foot down on the brake pedal, a connected lever pushes a piston into the master cylinder, which is filled with hydraulic fluid. That hydraulic fluid gets squirted along a system of pipes into other, wider cylinders positioned next to the brakes on each wheel. This hydraulic system multiplies the force of your foot on the brake pedal into enough force to apply the brakes and make the car stop. The brakes themselves are usually one of two types: disc brakes or drum brakes. Many modern cars have disc brakes on the front wheels and drum brakes on the rear wheels. More expensive models may have disc brakes on all four wheels. Only very old or very small cars tend to have drum brakes on all four wheels. Catalytic converters first appeared in the mid-1970s and quickly started to be used universally. It is a part of your car's exhaust system that converts harmful engine exhaust pollutants into something less harmful to the environment through chemical reactions. Most hydrocarbons, carbon monoxide, and nitrogen oxides convert into the less bad carbon dioxide, nitrogen, and water vapor. A muffler is a simple device used to reduce and manipulate the noise emitted by an internal combustion engine. It's important not to confuse mufflers with resonators, as mufflers control noise across the board while resonators target low RPM frequencies to reduce drone and other sound-related issues. That isn't to say resonators aren't a great item for tuning the note of an engine, it's just not the same as a muffler. How do mufflers cancel out this noise? If you were to open up a muffler, you would find a series of tubes, baffles, and chambers. These components work to reflect sound waves created by the engine. They are reflected in such a way that the waves actually cancel each other out. Different mufflers create a different range of noises. Some are designed to be silent while others are specifically designed to create what could be considered a growling sound. Rear axles, as you may have guessed, are located at the back of your vehicle. This axle is responsible for delivering power to the driving wheels. It comes in two halves, known as half shafts, which are connected by the differential. In most cases, rear axles are live, meaning they rotate with the vehicle's wheels. And sometimes there is also stub axles found in cars with rear-wheel drive is attached to either end of the front axle with kingpins. Stub axle can be split into 4 types depending on the stub axle's arrangement and its subcomponents. Elliott, this type is attached to the front axle by using a yoke, kingpin, and cotter. Reverse Elliott, this stub axle has the reversed arrangement of an Elliott stub axle. Lemoyne, in a Lemoyne stub axle, an L-shaped spindle and kingpin are used instead of a yoke. Lemoyne reverse, it has the reversed arrangement of a Lemoyne stub axle. The rear suspension of a car is the mechanical system that holds the car's body and frame aloft as the connection between the car and the road. The rear suspension includes the frame, or body connections in a unibody vehicle, joints, bearings and bushings, rods, shock absorbers, springs, wheels, and tires. The rear suspension's job is to work with the front suspension to conduct the car down the road smoothly and to keep it under control while it travels. On a basic level, the rear suspension prevents the vehicle's body from contacting the ground and keeps the tires in contact with the road. The steering system is used for changing the direction of the vehicle. The major requirements in any steering mechanism are that it should be precise and easy to handle and that the front wheels should have a tendency to return to the straight ahead position after a turn. A gear mechanism, which is known as the steering gear, is used in this system to increase the steering effort provided by the driver. This system makes car steering very easy as the driver does not have to put in much effort. Car steering is not only required on a curved road but also while maneuvering on busy traffic roads. The steering system allows the vehicle to be guided, i.e., to be turned left or right. Modern steering wheels also often have accessory functions built in, such as cruise control, audio system selection, and volume. Some steering wheels are even electrically heated. A serpentine belt, also known as a multi-rib or poly-V belt, is a drive belt that runs multiple components in a vehicle's engine. It is usually made of rubber, reinforced with fiberglass cords, and is shaped like a snake, hence the name. The serpentine belt appears in most cars' front of the engine block. The belt consists of multiple ribs designed to fit into grooves on the pulleys of the accessories and engine components. The strap provides a more efficient power transfer from the crankshaft to the features that need to be powered. The serpentine belt also helps reduce noise and vibration, allowing for more efficient packaging of parts in the engine compartment. The serpentine belt, driven by the crankshaft pulley, is connected to the engine. From there, it wraps around multiple other pulleys that power different components in the engine, such as the alternator, air conditioning compressor, power steering pump, and water pump. The belt then wraps around the crankshaft pulley again, completing the route. The belt, designed to reduce wear and tear, ensures that all components receive the proper power. The serpentine belt employs an automatic tensioner that adjusts for tension changes due to temperature or engine load. The tensioner ensures all parts receive a consistent amount of power, which helps maintain the vehicle's optimal performance. A malfunctioning serpentine belt may result from various factors, including a worn belt or dry serpentine belt, a worn-out pulley or wrong pulley alignment, exposure to coolant, cold weather, and a misaligned belt due to improper installation. A vehicle's engine cooling system serves not just to keep the engine cool, but to also keep its temperature warm enough to ensure efficient, clean operation. System components include a radiator to dissipate heat, a fan or fans to ensure adequate airflow for radiator cooling, a thermostat valve that opens when the desired operating temperature is reached, and a water pump, or coolant pump, to circulate coolant through the engine, hoses, and other components. Most vehicles now employ an expansion tank that allows the coolant to expand and exit the cooling circuit when hot, and to return when the car is turned off and the engine cools. The cooling system also incorporates elements of the cabin's ventilation system, because engine heat is used to warm the car's interior. An engine has many moving parts which eventually develop wear, as they move against each other. The job of the engine lubrication system is to distribute oil to the moving parts to reduce friction between surfaces which rub against each other. The lubrication system used by the Wright brothers is quite simple. An oil pump is located on the bottom of the engine, at the left of the figure. The pump is driven by a worm gear off the main exhaust valve camshaft. The oil is pumped to the top of the engine, at the right, inside a feed line. Small holes in the feed line allow the oil to drip inside the crankcase. The oil drips onto the pistons as they move in the cylinders, lubricating the surface between the piston and cylinder. The oil then runs down inside the crankcase to the main bearings holding the crankshaft. Oil is picked up and splashed onto the bearings to lubricate these surfaces. Along the outside of the bottom of the crankcase is a collection tube which gathers up the used oil and returns it to the oil pump to be circulated again. The ignition system's job is to ignite the air-fuel mixture in a gasoline engine. In addition to the spark plugs that spark in the combustion chambers, the ignition system consists of an ignition coil, which converts battery voltage to higher voltage, and the spark plug wires that join these components. Advancements have greatly reduced the need for ignition system service. Where distributor caps and rotors once needed replacement, electronic ignitions typically keep on firing. In new vehicles, spark plug replacement intervals are often around 100,000 miles. Spark plug wires still require attention and occasional replacement, though an individual coil-on plug eliminates those wires entirely. A powertrain is an assembly of every component that thrusts your car into motion. It includes engine, transmission, drive shaft, axles, and differential. When people talk about a high-performance sports sedan, we often hear how the vehicle is capable of smooth steering, acceleration, and brakes, as well as excellent body control and enhanced safe driving. Well, these techniques are important but not the be-all and end-all of a successful sports car. Its staggering performance numbers such as hundreds of horsepower or reaching 0 to 100 km per hour in seconds come from your powertrain, and nowhere else. As a source of power generation, a good quality powertrain is key to a better operating range, acceleration, and top speed. So, next time you accelerate your car from a standstill and feel a push of your engine power, just know that your powertrain propelled your vehicle. If you've ever driven a manual shift car, then you're probably familiar with the clutch. It's the third pedal that you have to press in order to change gears. This mechanism both engages and disengages your power transmission from the driving shaft to the driven shaft. It connects rotating shafts, and there can be 2 or more of these under your hood. If you drive a manual transmission, the clutch is connected to both the shaft coming from the engine and the shafts that turn the wheels. While the motor is going to spin constantly, you don't want the wheels continually spinning. A propeller shaft, also called as drive shaft, is an important component in automotive and marine industries. Its primary motive is the transmission of torque and rotational power from the engine to the wheels or propeller. It allows vehicles and vessels to move efficiently and smoothly. The propeller shaft plays an indispensable role in converting the engine's power into kinetic energy, thereby enabling the propeller to rotate at the required speed and move the vehicle forward. A front-engine rear-wheel drive car must have a long drive shaft connecting the rear axle to the transmission since these parts are on opposite sides of the car. Drive shafts are used differently in different vehicles, varying greatly in cars with distinct configurations for front-wheel drive, four-wheel drive, and the previously mentioned front-engine rear-wheel drive. The differential is made up of many parts. The main components are the ring and pinion gears. The ring gear is attached to the carrier assembly, and inside the carrier is a set of smaller gears. These smaller gears are often referred to as spider gears, which are made up of another set of pinion gears and the side gears. It is this set of gears that supplies the differential action. Following the power flow inside the differential, the pinion gear drives the ring gear, which rotates the carrier. The carrier then drives the smaller pinion gears, which in turn drive the side gears. The drive axles are splined into the side gears, which then drive the wheels. The differential is found in the front or rear axle assembly on all late model cars and trucks. In all-wheel drive, odd, applications, there will also be a center differential driving both front and rear axle assemblies. The gear shift is used to move a vehicle forward, in reverse, or remain neutral. On cars with a manual transmission, the gear shift is actually a stick shift. A gear stick, gear shift, or shifter, more formally known as a transmission lever, is a metal lever attached to the transmission of an automobile. The term gear stick mostly refers to the shift lever of a manual transmission, while in an automatic transmission, a similar lever is known as a gear selector. A gear stick will normally be used to change gears whilst depressing the clutch pedal with the left foot to disengage the engine from the drivetrain and wheels. Automatic transmission vehicles, including hydraulic, torque converter, automatic transmissions, automated manual, and older semi-automatic transmissions, specifically clutchless manuals, like VW autos, TIC, and those with continuously variable transmissions, do not require a physical clutch pedal. A timing belt is made of rubber with hard teeth capable of interlocking with camshafts and crankshaft's cogwheels. It is an integral component of an internal combustion engine responsible for synchronizing the rotation of the camshaft and the crankshaft. It enables the proper opening and closing of the valves of the engine during both the intake and exhaust strokes of each cylinder. The timing belt also plays an important role in preventing the piston from striking the valves, in an interference engine. A timing belt is usually a toothed belt with teeth on one or either side of the surface. Your car's suspension system is a protective lattice of shock-absorbing components such as springs and dampers. Your car's suspension helps ensure that your drive is safe and smooth by absorbing the energy from various road bumps and other kinetic impacts. Furthermore, it helps your tires stay in contact with the road by increasing tire friction. Think of the suspension of your car as a kind of carriage on which the car's main cabin sits. Your cabin is made more comfortable because it is sitting on the suspension, which is connected to the car's wheels. The vehicle and its cabin are insulated against impacts that are common when driving, even on well-paved roads. The main parts of a car's suspension include springs, which help to control the height and load of the suspension and cabin. Shocks, also called dampers, which absorb and dampen various kinetic energy impulses that your tires transmit when they contact the road. Your car's suspension system also likely has an anti-sway bar. The anti-sway bar can help to shift the movement of your wheels relative to your steering wheel. It effectively stabilizes your car's direction as it moves along the road. Your car likely has a suspension system for both its front wheels and its back wheels. Suspension systems can be either independent or dependent. Independent suspension systems are used when your back or front wheels move independently of the front or rear axle, respectively. On the flip side, dependent suspension systems are used when wheel direction is bound by axle movement. Shock absorbers are pump-like devices which keep your vehicle's tires in contact with the road surface by controlling the rebound of its suspension springs. As long as your vehicle's tires remain in contact with the road, steering, road handling, and braking response will be optimal, helping to keep you safe. Essentially, shock absorbers do two things. Apart from controlling the movement of springs and suspension, shock absorbers also keep your tires in contact with the ground at all times. At rest or in motion, the bottom surface of your tires is the only part of your vehicle in contact with the road. Any time that a tire's contact with the ground is broken or reduced, your ability to drive, steer, and brake is severely compromised. Despite popular belief, shock absorbers do not support the weight of a vehicle. A fuel tank is part of an engine system in which the fuel is stored and released into the engine. Though any storage tank for fuel may be so called, the term is typically applied to part of an engine system in which the fuel is stored and propelled or released into an engine. You may wonder, what are gas tanks made of? The fuel tank can be made out of plastic high-density polyethylene, which can be made into complex shapes, save space, and can improve crash safety. The gas tank can also be made out of steel or aluminum, which is welded from stamped sheets. The tailpipe is the final link in the exhaust system. It routes the exhaust gases, which have been cleaned up by the catalytic converter, away from the vehicle and into the atmosphere. The terms tires and wheels may be used interchangeably at times, but they are not the same thing. Wheels are entire metal circles that the tires are attached to. Each standard wheel comprises two major parts, the center discs and the rims. We will return to the rims later, with specific purposes and designs to create a fully functioning set of tires and wheels. Tires are rubber ovals that are designed to protect the wheels and to ensure that the vehicle has enough traction. If the vehicle has enough traction, then the driver will be able to control it easily. Each model of a tire is made up of a different mixture of rubber that has varied hardness and temperature-resistant properties. In addition to the rubber on the outside, the part that contacts the road, and the inside, the part that contacts the wheel, tires have a steel mesh in between the rubber. This makes the tire harder and more durable, which reduces the chances of a blowout. An exhaust system is used to guide the reaction of exhaust gases away from a controlled combustion inside an engine or stove. The entire system conveys burnt gases from the engine and includes one or more exhaust pipes. If your exhaust system is leaking or damaged, harmful toxins can enter the cabin and expose you and your passengers to deadly gases. Consequently, it's vital to visit a licensed mechanic if you notice any of the following symptoms: excessive vibration, loss of power, increased fuel consumption, thick smoke coming from your exhaust, noise ranging from rumbling, usually caused by an exhaust leak, thumps or clunks, often due to a broken muffler, and loud clattering, signaling trouble with a catalytic converter. The O2 sensor is responsible for measuring how much unburned oxygen is in the exhaust. It communicates with your vehicle's electronic control unit, ECU, to help figure out what the right air-to-fuel ratio should be for the best engine performance. Through monitoring these oxygen levels, the O2 sensor performs the important role of measuring this mixture so that the fuel injection system can adjust accordingly. O2 sensors can tell the ECU whether a fuel mixture is too lean, meaning there is too much oxygen, or too rich, not enough oxygen. O2 sensors became mandatory on vehicles starting in 1981, and many vehicles made after 1996 were required to have multiple oxygen sensors. The additional O2 sensors are used to monitor how the catalytic converter is operating. Number 31. Resonator. A muffler cannot take care of the droning sound of exhaust heard inside of your car. This is why it is paired with a resonator to tune the exhaust for a more appealing sound. Resonators are located in the vehicle's exhaust system, essentially between the catalytic converter and the muffler. While not all trucks and cars have resonators, all Lexus and other luxury models have them. The resonator is a complement to the muffler in that it removes high-pitched noises along with annoying hums and buzzes. It creates a smoother exhaust note, but doesn't affect volume. The resonator is designed to eliminate sounds at a particular frequency which bounce off the inside of the device, canceling each other. This is what gets rid of the annoying droning, creating a pleasant exhaust note. For car owners who hear a drone within a particular RPM range when driving, a resonator may be the answer to correcting it. An electronic control unit, ECU, is a small device inside a vehicle that controls one or several electrical systems in that vehicle. It tells electrical systems what to do and how to operate. ECU's core is a microcontroller, and it is controlled by embedded software. How does it work? An electronic control unit receives input from one or several parts of the vehicle and uses that information to take action if needed. For example, an airbag ECU receives information from crash sensors and seat sensors. When there is a crash, the ECU decides which airbags to deploy depending on where passengers are sitting. Then it tells the actuators to deploy them. Then the actuators convert the electrical signal into the physical value needed, using valves, injectors or relays. Vehicles may contain over 100 ACUs that, in addition to essential functions, like engine performance and power steering, control comfort and security features, such as parking assistance, memory seats, and airbag deployment. Just as humans need oxygen to breathe, a car needs oxygen for the combustion process. The air filter in your car plays a vital role in ensuring the engine receives clean air for combustion. An engine air filter in your car filters out dirt, debris, and other particles that could harm the engine. An engine air filter's purpose is to ensure only clean air enters a car's engine. Car air filters come in different shapes, panels, circular or cylindrical. They are made of a pleated material which filters the air and may be made of cotton, synthetic paper, or foam. Airbags are inflatable cushions built into a vehicle that protect occupants from hitting the vehicle interior or objects outside the vehicle, for example, other vehicles or trees, during a collision. The instant a crash begins, sensors start to measure impact severity. If the crash is severe enough, the sensors signal inflators to fill the bags with gas in a fraction of a second. Airbags don't typically require maintenance unless they deploy in a crash. In that case, they must be replaced at a repair shop that uses original equipment manufacturer, OEM, replacement parts to ensure that the new airbag is not counterfeit. Counterfeit airbags may fail to deploy or release metal shrapnel during deployment. A seat belt is a strap attached to a seat in a car. You fasten it across your body in order to prevent yourself from being thrown out of the seat if there is a sudden movement. The primary aim of a seat belt is to safeguard passengers during a car crash. It achieves this by restraining the occupants' movement, preventing them from being thrown around due to sudden stops or changes in momentum. In the absence of a seat belt, the car's inertia, its natural tendency to move, can lead occupants to be tossed inside the vehicle or even ejected out of it in the event of a collision. Seat belts play a crucial role in countering this inertia, ensuring occupants remain securely in place and minimizing the risk of injury. Headlights are one of the most essential parts of the car when driving down a dark and dingy road. A headlamp is a lamp attached to the front of a vehicle to illuminate the road ahead. Headlamps are also often called headlights, but in the most precise usage, headlamp is the term for the device itself and headlight is the term for the beam of light produced and distributed by the device. Headlamp performance has steadily improved throughout the automobile age, spurred by the great disparity between daytime and nighttime traffic fatalities. The US National Highway Traffic Safety Administration states that nearly half of all traffic-related fatalities occur in the dark, despite only 25% of traffic traveling during darkness. Tail lights are mounted to the rear of the car above the bumper. They are red in color and have accompanying white lights beside them to indicate when the vehicle is in reverse. When you're on the road, tail lights make another car aware of your presence so that you can travel safely in the dark. The windshield or windscreen is the front window, which provides visibility while protecting occupants from the elements. Windshields protect the vehicle's occupants from wind and flying debris such as dust, insects, and rocks, and provide an aerodynamically formed window towards the front. UV coating may be applied to screen out harmful ultraviolet radiation. However, this is usually unnecessary since most auto windshields are made from laminated safety glass. The majority of UVB is absorbed by the glass itself, and any remaining UVB together with most of the UVA is absorbed by the PVB bonding layer. A windscreen wiper or windshield wiper is a device used to remove rain, snow, ice, washer fluid, water, and slash or debris from a vehicle's front window so the vehicle's operator can better see what's ahead of them. Almost all motor vehicles, including cars, trucks, buses, train locomotives, and watercraft with a cabin, and some aircraft are equipped with one or more such wipers, which are usually a legal requirement. A wiper generally consists of a metal arm, one end pivots and the other end has a long rubber blade attached to it. The arm is powered by a motor, often an electric motor, although pneumatic power is also used for some vehicles. A proximity sensor for cars is a tool for identifying nearby items. These sensors operate using an electric signal and can sense an object without making physical contact. Car sensors warn if someone tries to break into or tamper with a vehicle, commonly used in security systems. Smart keys can unlock doors and help with parking by finding open spots when the owner is nearby. We utilize these sensors at times to estimate distance and prevent harm to the vehicle, person, or animal. A car hood, also referred to as a bonnet in some other countries, is the hinged cover that rests over the engine of a front-engine vehicle. Its purpose is to provide access to the engine for repair and maintenance. A concealed latch is typically used to hold down the hood. On vehicles with an aftermarket hood and on race cars, hood pins may be used to hold down the car hood. Hoods sometimes also contain a hood scoop, wiper jets, power bulge, and slash or hood ornament. Car hoods are typically constructed from steel and sometimes from aluminum. Typically, a car trunk is the primary storage area for cargo or luggage in a sedan, coupe, or convertible. The word trunk is used primarily in North America, while the word boot is often used in other English-speaking countries. Prior to the introduction of automobiles, the boot was a compartment that was built into a horse-drawn carriage. It was usually used as a seating area for the coachman. Later, it was used for storage purposes. The car trunk is typically located in the rear of the car in most models. In some vehicles in which the engine is located in the middle of the rear of the vehicle, and the trunk is located at the front. In some models, there have been two trunk compartments. A speedometer, an instrument that indicates the speed of a vehicle, is usually combined with a device known as an odometer that records the distance traveled. A speedometer or a speed meter is a gauge that measures and displays the instantaneous speed of a vehicle. Now universally fitted to motor vehicles, they started to be available as options in the early 20th century, and as standard equipment from about 1910 onwards. Speedometers for other vehicles have specific names and use other means of sensing speed. For a boat, this is a pit log. For an aircraft, this is an airspeed indicator. A fuel gauge is a device that measures the fuel level present in the vehicle. It consists of a sensing or ascending unit that helps to measure the amount of fuel. A gauge or indicator which is placed outside the fuel tank uses the information from the sensing unit to give the measure of fuel. The lines on the gas gauge are increments of 1/4 representing your gas tank's fuel level. Anything between two lines would be an eighth. If the needle were between 1/2 and 3/4, this would mean you have 5/8 of gasoline in your tank. More resources: what is a fuel gauge and how to fix bad fuel gauge? A fuel pump is an essential component in most internal combustion engine systems. It serves the primary function of delivering fuel from the tank to the engine. Without this vital component, the fuel necessary for combustion wouldn't reach the engine, rendering it inoperative. The working principle of a fuel pump is relatively straightforward. It creates a positive pressure in the fuel lines, pushing the fuel toward the engine. In most modern vehicles, the fuel pump is electrically operated and is located within the fuel tank. This design ensures a more consistent flow of fuel and helps maintain the required pressure in the fuel system. The temperature gauge in your vehicle is designed to measure the temperature of your engine's coolant. This gauge will tell you if your engine's coolant is cold, normal, or overheating. It is an important dial that is located on the dashboard of your vehicle. When the engine is functioning, and the coolant is doing its job, the temperature gauge needle should be somewhere in the middle between the hot and cold indicators. Normal temperature readings can vary from vehicle to vehicle, so don't be alarmed where yours settles. A trip meter is an instrument used for measuring the distance traveled by a vehicle, such as a bicycle or a car. That is most likely the trip odometer showing the miles traveled for trip A. Push the button there near the speedometer and it should show the mileage traveled for trip B. Push it again and it should show the current overall mileage on the vehicle. To read an odometer, look for the small rectangle usually containing 5 or 6 numbers. It is typically located near the speedometer. If your vehicle is newer, it may be digital. If your vehicle is older or less luxurious, it will be a physical, mechanical set of numbers. A tachometer, revolution counter, tach, rev counter, RPM gauge, is an instrument measuring the rotation speed of a shaft or disc, as in a motor or other machine. The device usually displays the revolutions per minute, RPM, on a calibrated analog dial, but digital displays are increasingly common. A rev counter simply shows the number of revolutions an engine's crankshaft, that's the rotating bit which converts the reciprocating motion in a car's case, the up and down motion of the con rods and pistons to circular motion, is revolving per minute, RPM, usually divided by 1000. The license plate in the picture is a blue and white sign. Every car must have a license plate for identification. This car also has many bumper stickers. These are decorations you can put on your car. This is a list of automotive parts, mostly for vehicles using internal combustion engines which are manufactured components of automobiles. The modern automobile uses a wide variety of accessories to make driving safer and more comfortable. Typical examples are self-starter driving and signaling lights such as headlights, tail lights, brake lights, parking lights, windshield wipers, horns, indicators, radio, heating, air conditioning systems, power steering, etc. Thank you for watching this video.